Morning. Pasensya na late gamay no. Kuan gamay na. Sige la. Okay, let's start. Oh, sabi. Okay, so last time we discussed continuation of the cross product, triple scalar product. I gave examples on how to prove vector identities using Levi-Civita symbol. Also, we discuss the bracket notation. So bracket notation is somewhat another notation for inner product and a dot product. You can actually find the angle between two vectors or two functions using the inner product. Okay, so let's now move to another topic. Mura siya og introduction sa Newtonian mechanics. So before we proceed to Newtonian mechanics, we will first discuss the kinematics of motion. Okay, so once you have motion, you can describe it via kinematics, and you can answer some problems using the dynamics of that system. So basically, we are now in this topic, differentiation of a vector with respect to a scalar, with respect to scalar. So we know differentiation, right? Okay, nakagraduate na ta og tulo ka calculus. Tulo ba yung calculus? Duha ra yung calculus, no?
Tulo, sir.
Tulo yung calculus. Okay, so graduate na tag tulo ka calculus plus humanapod mo differential equation, no? Sakto ba?
Yes, sir.
Okay, so hanas na ta mo derive, hanas na puta mo integrate, hanas na puta mo kuha og solution to some differential equations. Mo magina ang pinaka-importante sa physics major is kabalutan mo derive, basic nga derivation plus somewhat level up nga derivation, lisod-lisod gamay, complicated nga mga functions. Also, we know how to integrate, basic integrations, techniques of integrations. Usually, ang kasagara magamit sa techniques of integration is katong integration by parts. Di na kayo kagamit o trigonometric substitution. Pero naghihapon, no? Magamit gyapon nato na siya. And na ba may contour integral sa inyong calculus? Contour integral.
Basin, sir, na ambot. Basin lang.
Basin? Sige. So,
wala man ata, sir.
Wala?
Wala ko kabantayan na, sir.
Walay contour integral, no? Sige lang, okay ra. So, ang contour integral naman good kinasa sa complex analysis. So, when your function is a complex number, then there is this some integration called contour integral. So, na yung mga lisod ng mga problems. Like, for example, if you integrate this one, kana, ma-integrate ba mo ni using basic integration, dili, no? Sayon lang sa lang tao, no? Pero di mo siya integrate using gatong mga let u equals x, let du equals dx, and so on. Using also kung butahan mo x dira, sayon lang, no? Sakto? Kung butahan mo x dira, masolve ra nimo na, no? Pero kung wala x dira, then you cannot use this, you cannot solve this one using katong basic integration lang. So that is why there is this another integral. You can solve actually this using control integral, or you can solve this using spherical. I-change mo siya into spherical coordinates. So I think ma-solve na to na siya. Anyways, so we know vectors, okay? We know how to operate vectors. We also know triple products. We know how to multiply vectors. We know vectors, okay? Kabalo na taan yung vector, no? Kabalo taon sa ning vector. Bali, kung pangutanon mo sa ning vector, kabalo na mo ana, no? Kaya naana na sa math-free, na sa electromag, na sa theoretical mechanics. So, kada introduction sa kada subject, major subject, lagi na always ning vector. So, what do you mean by differentiation of a vector, and unsa na ang quantity ato makuha? So when you say for example we have a vector and then take the derivative of that vector, what will you get? Okay, so what's the physical meaning? What's that physical quantity? So if you consider a scalar, say phi, which is a function of s. Okay, take note, si phi is a function of s. Sorry, it is a scalar function. Okay, scalar function ang sakta, no? And this scalar function is differentiable. So may problema sa scalar function, no? Pwede niyo siya ma-derive differentiable with respect to scalar variable s. Okay, scalar variable s. So we know how to derive phi. Okay, we know how to derive phi, say to the nth nth derivative. Okay, nth derivative. Because neither part of the derivative can change under the coordinate transformation, we can equate this one. Yeah. This must be equal, right? This must be equal because your phi is a scalar quantity. So take note, by definition, scalar is invariant under coordinate transformation. So therefore, the derivative of that scalar phi is also equal to the derivative of the transformation, coordinate transformation of that phi. So we call that one as phi prime. Okay? So they must be equal. Equal lang gihapon by definition of a scalar, equal lang ang first derivative sa imuhang phi sa first derivative sa coordinate transformation sa imong phi. Take note na kung ako'y prime, it means that mo na imuhang coordinate transformation sa usa function. Since it is a scalar quantity, so it is invariant under coordinate transformation. Or you can solve, or you can express this in terms of this. Same lang ni sila dapat, no? Because phi is a scalar quantity, so therefore ang derivative is also the same sa katong iyahang coordinate transformation. Okay? So that is a scalar quantity. Now, if you let a another scalar function a, now we will go now to vector. Okay? If we will go now to vector a, and this a is a function s. Okay, why problema sa scalar, no? Scalar is when you take the derivative of scalar, then same ra siya sa iyahang derivative sa iyahang coordinate transformation. Now we will go to a vector quantity. So this one is a vector quantity. Okay. Question is, what will be the first? What will be the is is vector A differentiable with respect to any function or any variable? And what will be the first derivative or the derivative of the coordinate transformation of A? Okay, so A is a vector quantity. So we have, if it is a vector, then the derivative of this vector, okay, then the derivative of this vector A, okay, is defined as this. Same sa definition sa derivative. Mo man ang definition sa derivative, no? Limit of change of A with respect to S as delta S approaches to 0. Sakto ba? Di mo ni sa inyo ang calculus 1, I think gi-discuss nato ni na ang derivative of a function is defined as the limit of the change of that function over change of the variable, say x or s, as that variable x approaches to 0. So basically, ang akong isulat is just a definition of, this is just a definition of a derivative. And this is actually equal to the limit. So this is change in A. So we have the limit of this as a function of s plus delta s minus A as a function of s over delta s as delta s approaches to 0. Take note, pili siya multiplication, ha? A is a function of s plus increment delta s. Okay? Mo man yung definition sa derivative. So, kadumdum mo, no? Katong if we have a function x, recall, then f prime, we call this one as f prime. It means that this is the derivative of f with respect to x is just the limit of f, I think ang gamit nyo is h, minus fx over h as h approaches to 0. Okay? So, mo man ang the definition of a derivative. So, nakoy a function of f, f as a function of x plus some increment h minus a function of f over h as h approaches to 0. So, same lang na siya, no? Instead of using h, we use delta s, meaning the change in the increment of s. Now, we have this definition of A. This is actually the derivative of our vector A. Okay, the derivative of our vector A, limit of that function. So the derivative, so if this is a vector, then we have this property, the derivative, the property of its derivatives. Okay, the derivative of vector sums and products. So we know the definition. We know the definition of the derivative. We will also enumerate some properties of the derivative of vector sums and the vector products. Okay, so first, if we consider two vectors A and B, then the derivative of this vector A plus B, vector sum, this is vector sum, right? Is just equal to this. I-distribute lang nimo, no? Na ko dB ds. Take note, A and B are vectors. Okay, A, B are vectors. So, usahay, no? Take note, ha? Usahay, kaya di na nakubutangan o arrow vector sa taas. Okay? So, murag kabalo na ta na this A and B are vectors. Okay? So, if you derive the vector sum, then it is equal to that expression. Number 2, if you derive the dot product, okay, nako dot product, no? A dot B. So what will be the answer? This is equal to A. Distribute gyapon mo, no? dB ds plus dA ds dot B. Okay? Usahay, dili siya natin gitawag nga commutation relation. Nga usahay kay dili naman siya mabali, no? So, as is lang ni nga function, no? Na ko A dot dBBS plus dA ds dot B. Okay? Next is, what is the derivative? Number 3. Number 3, what is the derivative of a cross product? What is the derivative of a cross product? We have this, A cross of dB ds plus dA ds cross B. Okay, take note, cross product is anti-commutative. It means na, I think na sa inyong assignment, no? Proving that A cross B is equal to minus B cross A. So, meaning your cross product is anti-commutative. So, when you flip this one, kung i-flip ni mo ni, then dapat butangan mo siya negative na sign dira. Okay? So, importante ang kinsa nag-una sa imong vector sa imong cross product. Okay? So, we have dA ds cross B, or you can write that as negative B cross dA ds. Okay? Take note of that. Because take note, si cross product is an anti-commutative. Number 4 is we have last one. 4 this one, ds. We have a scalar function times a vector quantity. This is equal to scalar dds plus the derivative of a scalar times vector A. So these are some properties of the derivatives of vector sum and product. So we know that vector now is differentiable, okay? Differentiable with respect to some function, say s or what. So now, let's now go to application. So unsay meaning sa derivative of a function. So what do you mean by the derivative of a function? Sorry. Derivative of a function. So example of derivatives. We have this so-called velocity and acceleration. Okay. Mungutana ko, no? Naanaman sa Physics 41, no? Definition of velocity. What is the definition of velocity? So mag-start sa Aiko.
Sir,
How will you define velocity?
velocity, sir.
Yes.
Tuy, ilim sa tuy.
Aiko.
Kwan, sir. Nang the speed of something bitaw, sir, kanang gihatagan sa direction.
So to?
The speed of something in a given direction, ata, sir.
The speed of
Something that is given in the direction.
okay. What else? Aquino.
Sir,
How will you define velocity?
sir,
Velocity. Define velocity.
the rate of change of its position with respect to frame of reference.
With respect to frame of reference, sapit na, no? Kamay na lang.
Nalimtan na akong uban.
Hindi naman to, no?
And its function of time, sir.
Function of time? Sa to?
The rate of change of its position with respect to frame and reference, and its function of time.
Function of time. Wait. Nay sobra gamay, no? Nay sobra gamay tayo. Juven. Juven? Ano ba si Juven?
Yes, sir.
How will you define velocity?
For me, velocity is the specification of an object's speed and direction of motion.
Direction of motion. Sa to? Unsa ito?
It is a specification of an object's speed and direction of motion.
And direction of motion. Or same ra mo ni Aiko. Sige. So velocity take note. Hapit na ako nito ka Aquino, no? Nalang say gamay nga kulang. So velocity is actually the rate of change of position. Okay? So mora na. Velocity is actually the rate of change of position. Meaning same sa kang Miss Aquino, no? Velocity is the change in position with respect to time. So that's the velocity. Okay, so meaning ana kay nagdagan ang usa ka tawo given a period of time, you can actually get the velocity of that motion. So basically velocity is the rate of change in position. Okay, rate of change in position. So we can define velocity as the rate of change in position. When you say rate of position, when you say rate, it means that the denominator of that function velocity is with respect to time. Okay, kung may rate automatic with respect to time nila siya, no? Rate of energy. So na ko change of energy with respect to time. Rate of energy is power. Rate of change in velocity, you can get the acceleration. Okay, again, when you say rate, that is automatically with respect to time. Okay, so acceleration also is also defined as the rate of change in velocity. Okay, so as you can see here, there is a relationship between position. There's a relationship between position, velocity, and acceleration. So how will you relate these three: position, velocity, and acceleration? When I have the position, I can actually get all the informations, all the kinematic informations of that motion. Kung ako'y position, makuha na ko ang velocity, makuha po na ko ang acceleration sa usa ka motion. So how sa to ako ngono mag-start ta always sa position. Okay, mag-start ta always sa position. And then when we take the rate of change in when you take the rate of change in position, you will get the velocity. And then when you take the rate of change in velocity, you will get the acceleration. So mag-start siya always sa position. Now, if we let vector R, okay? If we let vector R as the position. Take note sa una, sa Physics 41 ninyo, ang atong ginagamit sa position is only X. Tama? Because we only consider position in one dimension. Tama ba? So muna kasagara kay X lang or Y lang ako ang position sa, or X o Y lang, no, in two dimension. But I will generalize the position as vector R. Vector R is a three-dimensional vector. So na siya component along X, na siya component along Y, and component along Z. So I consider or I let R as position of a particle with respect to a certain reference frame, to a certain reference, certain sustain reference frame. Okay, and this r is a function of time. Okay, this r is a function of time t. Now, so if I have this, say, initial condition, if this is my initial condition, usually kay nasa sa origin, okay, in 3 dimension, no? In 3 dimension. Then this vector, I call this one as vector r. So it has components. It has 3 components na components along x, components along y, and components along z. And these are is generally a function of time. Okay, so this is my position vector. We call this one as position vector. Now, if I have the position vector, then I can get the velocity and acceleration. Then the velocity v, denoted by v, and acceleration denoted by a, are defined according to this expression. V is just the rate of position, change in position. I call this one as dr dt, or some notation is we call this one as r dot. Okay, and a is the change in velocity, rate of change in velocity. This is actually equal to, since your v is dr dt, so pwede na ako siya masulat as this. Okay, in your calculus, so pwede na ako siya masulat as the second derivative of position with respect to time, or para dili ka taas atong notation, it is denoted as r double dot. Okay, r double dot. So take note, v can be written as r dot, and acceleration can be written as r double dot. Take note of this, ha. This is some notation. Muna ni atong notation for velocity and for acceleration. When I say r dot, meaning sa r dot is kuhaon nimo ang first derivative ni position with respect to time. When you say r double dot, kuhaon nimo ang second derivative ni position with respect to time. Okay, take note, ha. Specific ning r dot o specific ning dot o double dot sa kaning time rate of change. Okay, so with respect to time ni siya always, no? Kung may kog r dot, r double dot, r triple dot, meaning ana kay i-derive nimo siya with respect to time, and wala na lain. Kung may kog with respect to x, then dili na siya r dot, dili na po na siya r double dot. Nakuha. Always nimo timan-an basta ang derivative nimo is with respect to time, the notation is r dot and r double dot. Okay, take note of that. So r dot is first derivative with respect to time, r double dot is second derivative with respect to time, second derivative of position with respect to time. With respect to time, guna siya always, no? So this is now the definition of velocity and acceleration A. Now, what is r triple dot? R triple dot.
Jerk, sir.
Yeah, this one is called jerk. Okay, so changing acceleration with respect to time, the third derivative of position is actually equal to jerk. But we'll tackle this one sa, I think, mag-pan ba nato ni? Dili pa nato na siya matakol ng jerk karon sa kaninga chapter. Anyways, so dili kay ta, yeah, tama. So the third derivative of r triple dot is called the jerk. Okay, so moral, ano? Automatic, when I have the position, I can get the velocity. I also can get the acceleration of that motion. Now, we will now move to So we know the definition of velocity, we know the definition of acceleration and position. We will now move to we will now use this definition to solve some problems in three different coordinates, in rectangular, in spherical, and in cylindrical coordinates. Mag-start ta sa in rectangular. Kaya mo na yung pinakasayo, no? In rectangular coordinates, so ang goal is to write the position vector, the velocity vector, and the acceleration vector in first rectangular coordinates, second spherical coordinates, and third is in cylindrical coordinates. So unsa ni rectangular coordinates gani? So ang iyang common nga term for rectangular is Cartesian coordinate. Meaning ang Cartesian coordinate. Meaning na ako sa x, y, and z. Muna yung common, no? X, y, and z. But I will not use x, y, and z. I will use 1, 2, 3, no? 1, 2, 3 matong gamit, no? Na ko A1, A2, and A3 or E1, E2, and A3 sa unit vectors and so on. So I will use 1, 2, 3, not x, y, z in rectangular coordinates. So now, in rectangular coordinates, sayo lang, no? The position vector in rectangular coordinates, the position vector is equal to this. My r is equal to x1 e1 plus x2 e2 plus x3 e3. Tama ba? So na ko'y in rectangular coordinates, no? This is my x1 axis, this is my x2 axis, this is my x3 axis. And the position, say this vector here, any a vector, I call this one as position vector r, and this has three components, na ko'y x1, x2, and x3. Okay? x1, x2, x3 are x, y, z sa atong gamit na to sa una, no? So, my position vector is actually equal to this, na ko'y x1 unit vector is e1, x2 unit vector e2 plus x3 times e3. You can write this in terms of summation. You can write this in terms of a summation. This is summation of xi's, ei's. It's a function of a summation of with respect to I. Now, I know in Cartesian coordinate, I know the position which is equal to this one. Basically, makuha po na ko ang makuha next, the velocity. Velocity now in Cartesian coordinates is just the derivative of the position. We have velocity which is equal to r dot, okay? And this is equal to so ito, this is the derivative with respect to time of katong summation, no? Summation sa ako ang xi ei's. Tama ba? Because my position is given by this. My position vector is given by this equation here. Okay, this is my position vector. So take the derivative of that. What you will get is actually equal to this summation of xi dot ei. So if no, tama ba? Na ako'y ingani nga form. If you expand this one, so kung expand lang ko ni, you can write this as x1 dot e1 plus x2 dot e2 in 3 dimension plus x3 dot e3. Question karon, no? Sa sunod ni Juven, si J. Galos. A, B, C, D, E, F, G. Yeah, J. Galos. Question is this. Why is it that ang imuha ra gi-derive is only the xi, not the unit vector ei? As you notice here, for the velocity, this is the first derivative of my position with respect to time So giderive nimo ning kaning nasa summation with respect to time. But ang resulting niya nga derivation is equal to this summation of I xi dot ei. Question is nganong ang xi lang man akong giderive, nganong ang ei kay wala siya dot. Okay, wala siya ei dot. Gigalos na mo si
Kay
Gigalos.
scalar ang ano sir, ang x sir, position,
Scalar ang position.
ang
Pero
x.
pwede mo na ako i-derive ang vector, no? Tama ba? Maka-derive ako vector, sakto? Sakto ba?
Kay velocity raman sir, kung velocity change, rate of change in position naman sir, so mo to. Ang i-derive lang kay x.
Yeah. So, i-derive din mo ang position, but take note, position is a vector. Tama ba? So, you have to derive all terms sa imong position vector. Actually, giderive na to ni, no? Gidiretso lang nato, no? Giderive nimo, pero ang mahitabo kay mag-zero lang siya. Okay? So, why is it that nganong ang mabilin is only ei's? It's because unit vectors in Cartesian coordinates are constant vector with respect to time. Okay? So kung ko constant vector, meaning dili siya mag-change with respect to time. So if you derive that one, you will get a zero. You will get a zero nga answer. No? Tama? Kung ako
Constant din siya sir.
yeah. The I hat, the j hat, and the k hat are actually constants in rectangular coordinates. So, i-derive yun mo na actually, no? So, kung if we expand this one, expand na to, no? Na ko'y dt of x1 e1 plus x2 e2 plus x3 e3. So, there are actually 1, 2, by product rule, na ko'y 6 terms ani, no? Na ko'y x1 dot e1 plus x1 e1 dot plus x2 dot e2 plus x2 e2 dot. The last one is x3 dot e3 plus x3 e3 dot. But na 6 terms, pero ang tuluan na kay mag-vanish because this one is actually equal to 0. This one is also equal to 0, and this one is also equal to 0. Because E1, E2, E3 are constant with respect to time. Recall, si I hat, si J hat, ug si K hat kay dili man siya mag-change. In Cartesian coordinate ha, later sa spherical o sa cylindrical coordinates kaning mga unit vectors, okay, kaning mga unit vectors E kay dili constant with respect to time. So kinahanglan nimo siya i-derive. Nasa derivation, dili mag-zero ang derivation. So in Cartesian coordinate ha, this is in rectangular coordinates. Rectangular coordinates, okay? Si x hat or si I hat, si J hat ug si K hat kay dili man siya function sa time, tama ba? Kung ka notice mo, the I hat is going there, the J hat is going there, and the K hat is going to that direction. And these vectors, these unit vectors are not a function of time. So that's why when you take the derivative with respect to time, you will get 0. So that is why ang mabilin is only 3 terms, which is equal to this one. Okay? But dili sa tanan nga case, hindi ko kailan, no? This is only in rectangular coordinates. But in spherical and cylindrical coordinates, unit vectors are not, unit vectors are actually a function of time, t. Okay? A function of time, t. So you have to derive the unit vectors with respect to time. So I have this velocity Next is makuha na ko si acceleration. Acceleration is just the r double dot. Okay? So, or v dot, no? Pwede po kumusulat ng v dot. This is actually equal to the derivative of this xi dot ei. So basically, since AIs are constant with respect to time, so ang mabilin lang ang term is only this one. Xi double dot EIs. Okay, so this is now my expression of my acceleration. Okay. For example, lang tayo 5 minutes, so sige lang. Example. Consider my position R, which is a function of this, bt e1 plus ct minus gt square over 2 e2 plus 0 e3. This is actually projectile motion. As you noticed, tanawin mo ang x component niya, y component niya. This is actually kaning 1/2 gt square na ako'y v naught t minus 1/2 gt square. So this is the kinematic equation nga ato ang nadumduman sa physics 41. Gi-generalize na nato, no, in 3 dimension. I have my position vector. I have my position vector equal to this one, where B, C are constants, okay? Where B, C, ano pa G? B, C, G are constants. Okay? Are constants. Now, calculate the velocity. Find or calculate the velocity and calculate the acceleration. So this is very simple. Simple siya because in Cartesian coordinates, you don't need to derive the unit vectors e1, e2, and e3. Ang imo lang derive is only this. Kanya mga components. Kana o kana siya. So this is my x1, right? This is my x1. And this is my x2 as my x3 is 0. Okay? So velocity is just equal to this. Velocity is just equal to summation of xi dot ei. So this is actually equal to this expression here. The derivative of bt e1 plus the derivative of this function ct minus gt square over 2 plus derivative of 0 is just 0. Ano pa e2 3? E2. Derivative of 0 is 0. So, nalang ko doon ka term na mabilin. So, I have velocity is just equal to this. The derivative with respect to the derivative of bt, pila ni? Derivative of bt with respect to t is just
D.
b. So, na ko b e1 plus sorry. Okay. The derivative of ct minus gt square, pila ni siya?
C minus GT.
C minus
GT.
okay, C minus GT. So na ko C minus GT E2 and of course E3 0. So this is now my velocity. This is now my velocity. Okay. And then my acceleration is just you just have to derive the velocity. We have the derivative of this E1 plus the derivative of this minus CGT E2. So the acceleration is just equal to 0 mo rin, no?
0.
This one is minus G E2. And this is basic. The acceleration is due to gravity. minus G. Minus means going downward. Okay. E2 is somewhat the motion is along y nga axis. So that is why nakoy downward nga acceleration. The magnitude of that acceleration is G, which is equal to 9.8 meters per second. Also, how will you find the speed? Find the speed. Last na lang. So katong wala nang ka-oral karon sa Friday na po, no? So, ang last kay si Galos. Galos may last. Find the speed. Speed is just equal to, how will you solve for the speed? Last nga kon. Speed. Ayun na lang. Next time na lang. So speed has two terms. Okay? Nasa x component nga E1, nasa x component nga B, and then nasa y component nga C minus GT. And take note, ang speed, kung saan kayo pagkuha sa magnitude sa ka vector, it is always equal to the square root. Tama? Sakto? Kung may ko nakoy vector, and then kuhaan ako sa magnitude, ang magnitude is always the square root of the component square, x component square plus the y component square plus the z component square. In this case, nalang tayo duha ka components, the first component B and then the second component C minus GT. So I have always basta speed, basta magnitude gali, basta magnitude guys sa ka vector, it is always equal to square root of the component square. Okay? So nakoy first component is B, quantity square, not quantity but square lang, plus C minus GT quantity square. So this is now the speed of this motion. Okay, this is now the speed of this motion. And take note, speed varies with respect to time. It varies with respect to time. If you graph this one, if you graph the speed, then ang makuha nimo actually is I think it's a parabolic siya, parabolic nga going downward. Okay, because this is a parabolic with respect to time, so it is a parabolic with going downward. Okay, so we are done with the position, velocity, acceleration in rectangular coordinates. Next meeting we'll go to position, velocity, acceleration in plane polar coordinates. Okay, so medyo lisod sa gamay. Okay ra, sayo lagi hapon. And that's any question? Okay ra? So muna ang goal, no? When we have the position vector R, you can actually get the velocity and the acceleration of that motion by using first derivative and second derivative of that function. Okay, question wala?
None.
Okay, so let's end this session. See you next meeting. Wala abe? May absent no? Absent. Abe absent? Wala absent eh. Wala absent. Okay. See you next meeting. Goodbye.
Thank you, sir.
Sige.
Bye-bye.
Wala absent.